Hello guys, welcome back to lecture series on numerical methods. So in my today's video guys, I'm gonna explain to you all one of the very much important method, which is a Cholesky method, which we can use for finding the solution for numerical for equation in a three variable. Okay, for finding the solution of equation in a three variable, we use Cholesky method. Now see that this one is the one of the important method guys. Okay. So you all are familiar with already traditional method using Cramer's rule. You found the solution. Okay, solution for given equation in a three variable, or by solving the equation. Okay, by solving the equation you all have found. Okay, so you all have solved new equation in a three variable. Okay, so in my today's video guys, I'm gonna explain to you all Cholesky method. So it is important for your university exam, okay, for 5 marks. So let me explain method first, and at the end we go for solving some of the example. Okay, so here Cholesky method. So it is see that guys, this is completely Cholesky method, it is completely based on the determinant matrix concept. Okay, so you need to be familiar with this concept. Okay, so you can easily find out the solution, okay, using the Cholesky method then. And we know that for finding the solution, okay, for finding the solution using matrix, we know that the non-homogeneous solution. Okay, so what is the non-homogeneous solution for matrix? We write x which is equal to b. Okay, ax which is equal to b. This one is our non-homogeneous solution. Okay, this one is our non-homogeneous solution for finding the solution of a linear equation. Okay, so A means the matrix from which it comes from the given coefficient of x1, x2, x3 or xyz. Okay, x means x1, x2, x3, the variable which present along with this constant coefficient. B means another side for our given equation. Okay, yes. So see that we can easily generate the matrix A from given data. Okay, so we have to reduce matrix A in the form of, okay, so we have the matrix A here. Okay, so we have to work on matrix A first. So we are working on the matrix A. Okay, so if the coefficient of matrix A is symmetric and positive definite, then matrix A, okay, then matrix A we are going to write as a which is equal to L into L transpose. L into L transpose. Okay, but what actually meaning of L? L means lower triangular matrix. Okay, L means what it is mean by L? Lower triangular matrix. L means lower triangular matrix here. Okay, so what actually lower triangular matrix? That means above diagonal element is a 0. Okay, in our matrix, if above diagonal elements are 0, then we write it as the lower triangular matrix. Okay, now for example, let me write lower triangular matrix just for your understanding. I'm taking 3 by 3 matrix, you can take as a n by n. Okay, so I'm taking 3 by 3 just for your understanding. I just want to tell you all that how lower triangular matrix look like. Okay, so first L11, first row, first column. Okay, second row, first column. Okay, L21, L31. Okay, L21, L31. Okay, then after L22, L32 and L33 here. Okay, so now see that lower triangular matrix means we have only lower triangle. Okay, above this diagonal elements we have all the elements 0. Okay, so this one L we call it as the lower triangular matrix. Okay, for our L here. Okay, so we are going to express A as a lower triangular matrix into its a transpose. Okay, and a transpose means L transpose. How we are going to write L transpose? L transpose. Transpose can be written as row into column and column into row. Okay, so L11 0 0. So it actually it goes as the upper triangular matrix. Okay, L11 0 0, L21, L22 0, L31, L32, L33. This one is our 3 by 3 matrix. Okay, now see that I am going to express A as a lower triangular matrix into its a transpose. Okay, So that I'm going to write A as a lower triangular and its transpose. So for finding the values for L11, L21, L22, L31, we have to use this process. Okay. So now what we do in next step, now see that as we have A as a matrix A as L into L transpose, and our non-homogeneous system is X, which is equal to B. This one is our non-homogeneous system. Okay, so what I'm going to do, I'm going to replace A matrix over here. Okay, so L into L transpose multiplied by X. Okay, L into L transpose I'm going to replace here instead of A. Okay, L into L transpose multiplied by that X as it is, which is equal to B. What actually I have done, I just replace A here in our X, which is equal to B. Okay, so I written L into L transpose. So most of you all are thinking, why only lower triangular matrix? So it's not that necessary to replace only lower triangular matrix. You can replace A as a upper triangular matrix, U into U transpose. Not an issue. You can replace as upper triangular also. Okay, so I just have given just for understanding lower triangular. Okay, so instead of lower triangular, you can replace as a upper triangular too. Okay, Cholesky method says that either lower or upper triangular. Okay, yeah. So what I am going to do here in subsequent step, I am going to replace A here instead of that A. Okay, so A, L into L transpose, X out here and B here. Okay, yes, this one is our required step. Now see that I am going to little advance these steps so that we can get the X, Y, Z directly. Okay, so first of all we have to work on the value for Z. Z I am going to consider as another variable. Okay, so L into L transpose X. Okay, L into L transpose X, which is equal to B. I'm going to write this way. Okay, so what you do, L transpose X, just for a few minutes, L transpose X, consider it as the Z. Why Z? Because I'm going to consider this entire step as a Z, and I'm going to find out the value for Z1, Z2, Z3 up to Zn. Okay, and then thereafter I'm gonna replace this value L into all this constant, which is equal to B. Okay, this one is way easier to find out our required variables. Okay, so I'm going to replace L transpose X as a Z here. Okay, L transpose X as a Z. Replace L transpose X as a Z. So what we get here, capital L into Z, which is equal to capital B. Capital L into Z, L into Z, which is equal to capital B. This one is our required replacement after Z. Okay, yes. So using this one LZ, which is equal to B, you will get the Z1, Z2, Z3. You will get the three values. Okay, okay. So you will get the LZ, which is equal to B, as a 3 value. So once you get these 3 value, okay, once you get these 3 value, what you do, you replace here. So you will get this value. L transpose X is a Z. Z means Z1, Z2, Z3. Okay, so replace these values here. So L into these values, which is equal to B. Okay, so this one is our required process for finding the Z1, Z2, Z3. So once you are going to replace the value over here, you will get the value for X1, X2 and X3 directly. Okay, now see that X means here X1, X2, X3. You can easily find out the value for X1, X2, X3 using this one. That one is the required solution. So now see that, guys, I just give one little overview for our given Cholesky method. Okay, this one is our Cholesky method. So see, guys, here this one is a Cholesky method, Choleskys, Cholesky method. Okay, important for SPPU exam for 5 marks. Okay, so I hope you all have understood the process. Okay, how can we find the value for x1, x2, x3 as a linear variable. Okay, yes. So if you want, you can note it down these points. So once we continue some of the example, guys, it will be crystal clear for us the concept. Okay, so we need some example to understand this method properly, but I hope you all have understood what are the concept here, what are the variables. Okay, so we are going to apply this one in the example. Okay, so that's it here for our today's lecture, guys. I hope you all have understood the method. Okay, so in my next lecture I'm gonna explain to you all, guys, directly the example based on the Cholesky method. Okay, so that's it for our today's example. So thank you everyone. Thank you for my today's lecture.